So to help you get started in this math lab solving trig equations graphically, you can either print a copy and then you'll sketch your graphs and write your answers in pencil and scan it in to upload, or you can open up this Word document copy that's in the assignment, and you'll be able to copy and paste your answers from that Word document, from Desmos into that Word document, save that file and upload that instead. But in order to get started, you're going to need to open up Desmos, and we're going to follow these instructions to solve 2 cosecant of x minus 2 equals 1 over sine of x. We're going to solve that equation graphically using these two methods, but just one at a time. So first thing we want to do in step 1 here is to graph each side of the equation separately in Desmos after adjusting the settings for the window to go from 0 to 2 pi along the x-axis, and we want enough of the y-axis to see where these two curves intersect. And for this first method, we're taking the left-hand side of the equation and graphing that in one line, and then the right-hand side of the equation will be graphing that in another line. So I'm going to slide this over here so that we can look just at Desmos, and first thing we want to do is set up those window dimensions as it was specified in the instructions. So we click on this little wrench icon here, and coming down we're going to turn off these minor grid lines. Then under the x-axis we're going to change the smaller end to 0, and the larger end of this scale is going to be going all the way out to 2 pi. And let me do that again. Notice I type the 2 and then I literally type in the letters on the keyboard 2 pi, and when I hit the I, it turns itself into the pi symbol. Okay, I want the increments between 0 and 2 pi to go by pi over 4. And to get that in there, I typed pi, the letters, the divide symbol, and then the 4. And notice in the background here, it's going from 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, etc. I'm going to press enter. There we go. Now I think I'm going to actually, instead of starting at 0, I'm going to go back a little bit here to negative pi over 4. And make this increment be pi over 4, and there we go. So now I'm going negative pi over 4, pi over 4, pi over 2, right, and so on in my scale. Now the y-axis is currently going from negative 6 to 6. I'm going to change that from negative 3 to 3, and I'm going to step by ones, so you can see in the background here that the y-axis is going in ones. Okay, we want to be in radian mode, not in degree mode, and I think that looks good. All right, next in the y1, we're going to type in the left-hand side of our equation. So y equals, and 2 cosecant of x, and then minus 2. And when I press enter, I can see that first interval. And now in the y2, I'm going to type in y equals 1 divided by, and that's sine of x. And that's coming from the right side of our equation. And I press enter. Now if you'd like to see more of this graph, right, if you use this minus sign here, that's going to zoom out for you, and you can see then clearly that the red, the 2 cosecant of x minus 2, is these alternating U shapes. Right here we have some vertical asymptotes at 2 pi, pi, 0, negative pi, and then for 1 over sine of x, you should recognize that as a reciprocal identity. So we're actually in this blue graph, we're graphing the cosecant of x. And that's the parent graph of cosecant of x. You see right there in the blue those alternating U shapes. that go from -1 to 1 as an undefined area, and they also have asymptotes at 0, pi, 2 pi, 3 pi, etc. Now, in order to see where the solutions are, we want to see where those graphs intersect. And so I'm just going to click with my cursor on one of those graphs. Here I clicked on the red one, and notice these points of intersection that just pop up automatically, and they're gray. So when I click on one, that turns it black so I can see it a little more clearly. And here I can see that pi over 6 comma 2 is a solution. It's the x value that is going to be the answer, the solution to that equation. So this equation has an x value of pi over 6. That is a solution. Then the next answer is right here at 5 pi over 6. Okay, and I want all the solutions from 0 to 2 pi. Here's 2 pi. So if I was going to use this as my graph and I needed to copy and paste it into the lab, I would open up my snipping tool, hit New, and I want to make sure I show all the solutions that extend from 0 to 2 pi. And so here they are. So I would clip that with the snipping tool. I would go to Save Snip, give it a name, and then I would have it in case something happened later I needed to retrieve it. And then I would hit Copy and paste it into that Word document and save, and then I would move on to the next question. So that's the first method that we see here in the math lab for solving this equation, method 1, finding points of intersection. And we can see down here at the bottom, we did find both of those solutions, pi over 6 and 5 pi over 6. Now, method 2, for solving the same problem, you can do this with any of those equations. Method 2 is to, instead of entering two separate lines in our y equals, instead of doing the left side as an equation and the right side as an equation looking for points of intersection, in method 2 we set this whole equation equal to 0, and then we look for the zeros along the x-axis. So let's go ahead and give that a try next. So back to Desmos, I'm going to go ahead and delete those two, keep my configuration here the same for the dimensions, and this time I'm going to do y equals my 2 cosecant of x minus 2. That was from the left side of the equation, but now I'm going to subtract over the 1 divided by the sine of x to the other side. Okay, and so now I can, instead of looking for points of intersection, I'm just going to click on this green graph that appeared, and notice again here in the center the little gray critical points that show up. We've got the zeros here, pi over 6 comma 0, so pi over 6 is a solution. Then there's another one here at 5 pi over 6 comma 0, and there's my second solution. We're only looking for the zeros. Don't get distracted by this this minimum extrema down here at negative pi over 2, negative 1, or of this relative maximum at 3 pi over 2, comma negative 3. Those are not solutions because they are not zeros. They're not x-intercepts. Only these real zeros are going to count as solutions from 0 to 2 pi. So we'll open up the snipping tool, click New, and then we would drag a box that shows all the solutions in that interval, one lap around the circle from 0 to 2 pi. And that's the image that you would want to save a backup and then copy here with the copy button and paste it into the Word document if that was the problem that you were trying to solve. Okay, so again, that was the second method here in the math lab. On the front, the method number 2, finding the zeros method. So we've looked at both of these methods now, finding points of intersection, method 2, finding the zeros. When you're ready, you can go down to number 1 on the back and start trying those problems. Now for number 1, it makes sense to use the zeros method because it's already solved for 0, right? Number 2, you really want to decide for yourself whether you want to graph the left side and the right side and use that intersection method, or if you prefer to subtract over the 4 cosine of x, enter it all on one line and just look for the zeros. That's a personal preference. It's up to you. Now, if you don't have access to Desmos, or you prefer using a graphing calculator, at the bottom of the first page, so right here in this section, you can see the same process will work when you're using a graphing calculator, only there are no buttons on the graphing calculator for the reciprocals, the cotangent, the cosecant, or the secant function. So if, let me close out Desmos here. So if you want to use instead, okay, so if you want to use instead the graphing calculator, and I'm going to show you how to do that next. So I'm going to use my capture tool here. Once it pops up, there we go. I'm going to use that capturing tool to grab this problem. There we go, and that should post so I can close this and see this a little bit more clearly up here. Oh, it's got a big line drawn through it. Oh well, that's fine. So here's our equation that we're looking at, and here is a TI-83 graphing calculator off to the side. And you'll notice there's a button here for sine, cosine, and tangent, and we don't have any buttons for the cosecant, which is what we need here to type in 2 cosecant of x minus 2 using the intersection method. So instead, in my y1, I'm going to remember that cosecant is the reciprocal of sine, and enter that as 2, and then divided by the sine of x, because the dividing by sine, that's the same as cosecant, and then minus 2. I press enter, and in my y2, I'm going to put the right side of the equal sign, which was 1 divided by the sine of x, and press enter. And now in the calculator, I hit zoom, and zoom trig here, number 7, that will get me a window that goes from negative 2 pi to positive 2 pi in increments of pi over 2. Okay, and in order to find these points of intersection, I'm going to have to press second trace, and then number 5 here is the option to find a point of intersection. So I press enter for number 5. Now the graphing calculator screen is going to ask me 3 questions at the bottom. So the first one is asking me for the first curve, and I'm going to use my arrows here to advance, and notice up here, if I go back a little bit, see that little X that's blinking, that point coming down? That's the thing that is telling me which curve I'm on, and I want to be right near that point of intersection I'm trying to find, right? So here is the curve 2 divided by sine of x minus 2. It's blinking on it. I'm right near that first point of intersection, so I press enter. Now it should automatically hop over to the other curve that's nearby. So I see in my y2 in the corner here is now 1 divided by sine of x. All right, that's my second curve. At the bottom it's asking for the second curve. I'm on it, so I press enter. Now the third question that pops up at the bottom is, would you like to take a guess? And as long as your blinker, your cursor here, is near the point of intersection that you want to find, because notice there are multiple, there's 1, 2, 3, 4 points of intersection in this window. I need to be close to the one that I wanted to locate. So you could arrow over to the left or the right. If you want to get a little closer to it, that's fine. And then when you're ready, you press enter. And there at the bottom, we can see the calculator estimates the point of intersection to be at 0.52359.878, 2. Now these calculators are old, and so they don't show you the exact value in radians. They give you a decimal approximation. So you would need to look at this table here that I provided, where you can see that pi over 6 is approximately 0.524, pi over 4, 0.0785. We can look at that table and see that pi over 6 is the closest to this value that I have popped up here. And if I, in my calculator, I compare the answer that I have to what pi over 6 is over here on the side, see pi over 6 is exactly 0.52359877756, and that does round to what I see on my intersection screen. So I would say that pi over 6 is the solution that I found for this point of intersection right here on the picture. Okay, now to find the other point of intersection, because I can only find them one at a time in the TI-83, I have to go through that sequence again. So I hit second trace, then I'm going to arrow down to number 5 for intersect, and I want to check my Y1 to be the first curve, and I want to arrow now closer to the second point of intersection that I'm trying to find. So my Y1 is 2 divided by sine of x minus 2. That's what I want for first curve, so I press enter. Now it's asking for the second curve. I look up in the corner, I'm on Y2, 1 over sine of x. That's great. I press enter. Now it wants the guess. And that guess needs to be, just like we said before, it needs to be as close as possible to the actual solution that you're trying to find. So I think I'm pretty close. I'm going to press enter, and here it found it. So x equals 2.6179939 is my decimal approximation, where y equals 2. So I come over to my table, and pi over 4 at 0.785, that's too small. Pi over 3, 1.047, that's too small. Pi over 2 is too small. 2 pi over 3 is too small. 3 pi over 4 is too small. And then here it is, right? At 5 pi over 6, it's approximately 2.618. That's the one. So that will be the exact value of my second solution. And these angles that you see in this table that you're using to convert to exact values from your decimal approximations in the graphing calculator, those are just the special angles from the unit circle, right, from 0 to 2 pi, which is the interval that we're looking for answers within. So you can tell that this TI-83 method is a lot more work than using Desmos. In Desmos, you just type in the equations as you see them, because Desmos recognizes cosecant and cotangent and secant. You don't have to convert them using reciprocal identities. And also, once you've graphed them in Desmos, you just click on the graph and it shows you, it highlights for you and shows you the exact values of all of those points of intersection. So this is a little bit more work, but it's good to know how to do this method, because when you're taking standardized tests like the SAT or your Keystone exams, if you're in Pennsylvania, you can use a graphing calculator, but at least right now you're still not allowed to use any other graphing technology like Desmos app. Or a GeoGebra app, for instance. So hopefully this gets you started with the Math Lab, and feel free to reach out if you have questions.